name is Michael Agander. I'm 29 years old. I am a mechanical engineer from ETH Zurich. I'm the co-founder of Microcaps and act as the CEO at the moment. A CTO at the moment, sorry. Normal. Yeah, so I have a strange background, if you want. So when I was 19 years old, I joined the Swiss Air Force as a pilot candidate. And then I was employed by the Swiss Air Force for 4 years and was flying there. And then I had to stop doing that because of medical issues. I got nauseous with long rotations. I was 24 years at the time, and then I figured let's do something completely different and enrolled in the mechanical engineering program at ETH. Yeah, so Microcaps is, as the name already says, it's all about microencapsulation. Microencapsulation is typically used whenever you have an active ingredient that needs to be protected from the environment and then delivered to its target. So I'll give you two examples. One example is a fragrance in a washing powder. So there's no use if it smells really nice during the washing cycle. It actually has to smell nice when you take your sweater out of the closet. The second example is a pharmaceutical ingredient that needs to be protected from the acidic environment of the stomach. This is done through a microcapsule, and then the release happens later in the intestines, where the active pharmaceutical ingredient can actually be uptaken by our body. Now, the problem with today's microencapsulation is that the methods to fabricate them don't allow size control. So the size of these microcapsules all vary completely. Now, the size of the capsule has a significant effect on the release of the said active ingredient. So you don't really know how much of the ingredient and when and where exactly it is released. Now the solution we propose to this problem is to have all microcapsules at exactly the same size, which means they all behave exactly the same, which allows us to tailor A, the doses of the ingredient, and B, the timing of the release. Now there is a problem there that it is possible to fabricate such size controlled microcapsules. However, the state-of-the-art device allows only a throughput volume of 5 grams per hour. Now, to put this in context, to fill a single medical pill, it would take more than a day, which is obviously not feasible for industrial purposes. Now, what we managed to do is to highly upscale this process. So we are now at production rates of 5 kilograms per hour, which is a factor of 1,000 higher, and which is more important, it's fully scalable and fully reproducible. So we can build multiple devices that have the exact same output. So for the first time now, the industry has access to fully size controlled microcapsules at industrial volumes, and that's what we do. So the first 3 years in mechanical engineering, there's some choice in what you can do, and then there's a lot of broad background information. I have done during my studies, I have done a so-called focus project, which is 1 year, and it's a product development. So from first idea to first prototypes, which is, at the time I didn't know that I was going to do a startup, but it's certainly related to what we do now. It's having an idea and then making first sketches and then follow through, go towards a prototype, test iterations, design iterations, etc. In the masters, so after my bachelor's thesis, which I've done here, I was very interested in the micro nanotechnology on the one hand, and then this entire biomedical engineering field. So I did in fact tailor my masters towards these topics, but nevertheless at that time I did not know yet that I was going to start this company together with Alessandro. In the final year, I have to say that I knew it already, and then I took some last courses that are specifically useful to what we do now. So one is a technical one, that was polymer sciences, and the other one was actually I enrolled in a marketing course as a guest. So at the moment we're a team of 10 people already. We have mechanical engineers working, material scientists working here, chemist, and then actually a business guy from HSG St. Gallen. So it's a broad background. So of course, if it's a technical position, there needs to be some tech affiliation. However, you don't need to be a chemist to do what we're doing. I'm Exhibit A for that first day in the lab. I think I dissolved the Petri dish in chloroform just because I didn't know any better. This is learnable stuff. What is most important is we try to screen for talent and for enthusiasm. Motivated people that are willing to try out new things, people that are able to work by themselves without us standing next to them all the time. And that's the most important. But obviously, yeah, if we're looking for someone to develop a capsule system, a chemistry background or a material science background would help. So at the moment we have 3 different things, I think. So there's people doing master thesis here, which is for us the favorable case because people stay 6 months, and in 6 months full time you obviously get a lot further than with the comparable bachelor thesis, which is 3 months 2 days per week. So there's a significant difference there. We do have 3 bachelor theses at the moment, and then we also have this labor practica, I don't know the word in English, which is also a full time but 8 weeks, which we do. But the master thesis is the favorable there because it's 6 months full time. Also, I think that the projects are more interesting because it allows you to cover more during 6 months. So that's the ideal case. One of the projects is the upscaled machine of our microcapsule fabrication. So you have to see the problem is we're moving from lab scale to industrial scale, and there's quite a gap. So when we started, this entire thing was working on syringe pumps with the largest volume being 60 milliliters, and we want the production at 5 kilograms per hour. So obviously a syringe of 60 ml is not ideal. So we had a task, so move from this 60 ml system to a system that is capable of handling 5 kilograms. Now it's all new developed, so it's a custom-made system. You cannot go on AliExpress and order one. So that was or still is the challenge of the mechanical engineering thesis, to build a prototype, number one, a machine that is capable of handling 5 kilograms per hour fluid supply, fully controlled, fully automated if possible, and that's quite a big challenge. So Nico, our engineer, is working on that since 4 months and is doing great progress. So when you see we started 1.5 years ago, it was the 2 of us, the name Microcaps didn't exist, and it was just an idea, hey, we have a cool technology, I think we can commercialize this. A month ago we founded the company. We're a team of 10 people, so that was what happened within 1.5 years. So if you try to plot this into the near future, my prediction is that we're going to move out of ETH in a year to our own facilities or bigger rented facilities, desirably double the team. Then, which is most important, have custom paying customers, right? Otherwise it's going to be very hard.